the internet infrastructure. First, we'll have to talk about the ISP, who is ISP, Internet Service Provider. So, what really is internet? Do you know the definition or the structure of it? There's nothing like that. No agreed definition of its structure. But distinct levels within the structure are there. In the structure, there are distinct levels. Initial function of an internet service provider, that is ISP, to give internet access to an individual or a company. That was the initial duty of it. This function now performed by an access ISP. The term used is access ISP. They connect to middle tier or regional ISPs. So now we come to the tiers, different tiers or levels. Tier is level. So they are connecting, the access ISPs are connected to the middle tier, or another term is regional ISPs. They in turn connect to tier 1, going up, or backbone ISPs. So they are called backbone ISPs. These are access ISPs, backbone ISPs. Backbone is like the very important structure, backbone. Even on an animal or even human, backbone is very important, the structure. So the structure. An ISP is a network, and connections between ISPs are handled by Internet Exchange Points. So there's a thing called IXP, Internet Exchange Points. They will handle these connections between ISPs. The tier 1 ISPs are at the top of the hierarchy. So you know the meaning of hierarchy from levels, from the top level going down lower levels. So the tier 1 ISPs are at the top of the hierarchy, along with major internet content providers. There are others who are called content providers also. Generally, all ISPs are content providers. They give content. Router, another term commonly used. Router, a device that acts as a node on the internet. So on the internet, before the PC is visible, the router is the node. From the router only, the PC is connected. Each router is connected to several other routers, and its function is to choose the best route for a transmission. So if you want to send an email to someone, there are different routes. There are different routes. And how do you find the best route, and who finds? That is why it's called a router or router. The pronoun says router. Finding the best route. Public Switch Telephone Network, PSTN, often referred to as POTS, which stands for Plain Old Telephone Service. Let's have a quick look at what this PSTN is. Public Switch Telephone Network. I'll do a brief explanation also. Imagine that these are users or telephone subscribers, A, B. Remember, we are talking about the olden days system. So telephone subscriber. Here, and in another town, far away, and I'll C and D and all that. So how do you have, there are 100 subscribers here. There are 100 subscribers in this town. Are you going to connect these 100 lines from here to there? And imagine there's another town with another 100. So will there be like 100 here, 100 there, 100 there, from there, 100 here, 300 or more? No, it's not like that. It's called switching, right? That's why I said public switch telephone network. You may have seen on the road. On the road, you may have seen like cabinet-like boxes on the pavement, side of the pavement. They're like tall, like an almirah or a cabinet. Inside, it's a metal cover you can see. Sometimes the maker, the technicians or engineers, they come and open this, and you can see a whole lot of wires, tiny meaning very thin wires connecting switches, lot of switches. So when they want to add a telephone line or a big cable, so they come and open this and do their work here and add those lines. So what happens is once once from this switch to that one, if there are 100 here, there would be 100 to the other one, that town. Maybe less. So then how are you going to use this? When A wants to connect to C, will take, or let's say B will get first connect to this one, from there to another switch on this side, and then from there to C. The moment this call is over, if another one takes a call, say A wants to take a call to C or maybe D there, then what happens? This line here can be used by them. It's reused. So all the time these lines are used for different call, right? So it's also called plain old telephone service, which the abbreviation is POTS. Initially, the telephone network carried analog voice data. So initially, only for voice, and the digital signals were not developed at that time. So the analog signals went. The computers wanted to use them. Digital data could be transmitted using modems. That is, still you are using the normal cables, the telephone lines, but computer sends digital data. So because of that, that digital signals have to be translated or converted to goes. So from here to there it goes as analog signal. Then the computer receives, it has to be digital again. Because the computers don't understand analog signals. So modulate, demodulate, right? Convert, deconvert. That's why a thing called modem was in place. Modem. Using modems only, digital data would be transmitted. Dial-up connection. Dial-up connection. Like taking a call. Like taking a call, you have to connect from time to time. And they were charged per minute. Internet usage was at per minute charge. Then, and also they were moderate speeds, very small speeds, low speeds. Then an organization could pay for a lease line service that provided a dedicated, permanently connected link with guaranteed high transmission speed. Again, organization could pay for a lease line. Lease line is like this. They take one connection and dedicate it, this B2C connection. That's all. No one else can use this. Even if this is not in use, they're not using, both sides are off even, this line cannot be used by the other. So that's why you have to pay a high amount. Actually, you can't buy them. You have to pay a lease. So it's called a lease line also. Annually, you have to pay the lease to the service provider. Dedicated and permanently connected. And high transmission speed also guaranteed. Lease lines were used for vans and MANs. Vans, wide area network, MAN, metropolitan area networks, like intercity. Recently, PSTNs have upgraded to fiber optic cables, that is digital. So recently now they have upgraded these analog metal cables to fiber optic, which is which carries digital signals. So there was a big revolution in the transmission speeds, the communication field. So it came to be known as broadband connection. The bandwidth is very wide, very broad. That means bandwidth is the amount of data carried BPS, 100 Mbps is 100 megabits per second. Wi-Fi hotspot technology, another revolutionary thing which improved the communication. That's an access point. Access point has a connection to a wired network providing internet access. So initially, the line comes to your home. Inside the home, you have the, once it comes here, inside you have the router. And from router, you can have Wi-Fi to your computer. But nowadays, you can even have without a wire. So this is the wired connection up to the router. That's why it says access point has a connection to a wired network. So it's a wired network and from inside the house only, internet access through Wi-Fi. But nowadays you see many service providers give without without a cable from the ISP directly to the router and then the computer without wires. And that is done by cell phone network. The mobile phone equipped with the appropriate software communicates with a standard cell tower to access the wireless telephone network, which in turn provides a connection to the internet. You have seen those towers, very tall towers, with the antennas transmitting and receiving, which enables the cell phone network to operate, mobile phones. Applications that make use of the internet. WWW. World Wide Web is a distributed application which is available on the internet. So internet is not software, it's a structure, it's a hardware part. But other services are there which makes use of these infrastructure. So WWW is one distributed application which is available on the internet. Specifically, the web consists of an enormous collection of websites, each having one or more web pages. So it is a collection of huge number of websites. Then what is this cloud computing? Cloud computing is the provision of computing services usually via internet. An organization can establish its own private cloud. All right? Know about private cloud? Google Drive, various services are there, third parties. You can have, some are free, some you have to pay. So an organization can establish its own private cloud. The organization takes full responsibility for creating and managing the cloud installed on site and connected to a private network. So not connected to the internet, private network. There may be in a large organization, there are branches and all that. They can have their own cloud so that providing the staff members, the workers, store their work and access other people's work. The organization outsources, this is the second method. The organization outsources to a third party. Outsources means giving it out to another person to make, third party. The creation of the cloud as well as the management of an on-site installation connected to a private network. Still private, right? Then the third one is the organization outsources the creation and management of an internet accessible system by a third party. The difference is internet accessible system this time. So the three types are that public cloud is created managed and owned by a third-party cloud service provider. So that is public demand. These three mentioned here available only for that organization. That's why it's called a private cloud. Private cloud, public cloud, or managed and owned by a third-party cloud service provider. There are file servers, application servers, right? File server, when you do about the networking, you know, that file server, the files are kept in the main computer. The others, they are not worried. They don't have even a hard disk. They can even work without even a hard disk on their terminals or PCs. They are connected to the server and it's serving this client. Client is a user. Server will give whatever that is needed, like file or applications by an application server. So accessible via a browser. You have to access it through a browser. What browser? A web browser. From any suitable device in any location. Definite advantage, isn't it? You don't have to carry your computer wherever you go. You just need a device with a good internet connection and you can access all your work. Large mainframe computers or server farms are used for that. So many millions, even maybe billions of people using these services, then your bandwidth and the processing speed, they have to be very high, extremely high. For that, they use a thing called server farm, like a farm. Many CPUs working in parallel, like what? The work is shared by all these terminals or CPUs. This is an example of a server farm. Key terms: private cloud, owned by and only accessed by an organization. But public cloud, owned by a cloud service provider for general access. Private is only for that organization, public, anyone can access. Then we learn about bit streaming. In general, before data is transmitted, it is stored in bytes, which can be transmitted one after the other as a byte stream of bytes. Because of the file sizes involved, streamed media is always compressed to a sequence of bits, a bit stream, and it's called the bit stream. Compressed and sent like a stream in bit form. Media stored on a website. Let's look at this instance. Some media, maybe a video file or something, stored on a website. It's on a website. Now you want to access it. One way is download a file, then listen to it or watch it at some future convenient time. When you do that, you can't listen to it until the file is completely downloaded. And you can watch any number of times later on. Second way is viewing or listening on demand. The incoming media data are received into a buffer created on the user's computer. Buffer is a temporary memory area. The user's machine has media player software that takes the media data from the buffer and plays it. This is an example of your watching a YouTube video. When it is downloading, before it is finished, also you can watch. And there is a buffer. The incoming media data are received into a buffer created on the user's computer. That is, as I told you, a memory area. You would see on the video when it is being played, you see a red line moving, progress bar of the playing. And when being ahead of that, there is a gray area also moving. So that's a buffer. First, store it there, and then the media player, the machine, your media player, which is on the machine, will take from that buffer and play it. And the third way is real time or live transmission. That is exactly what is happening now. Now, when now this is, I'm having a Zoom meeting and it is a live transmission. Right now, instantly, you can hear and listen. It is hear and watch, hear and see, listen and watch. Okay, so that is real time or live conversation. Let's look at the schematic diagram of bit streaming. Bit streaming with the buffer. The media server is here, so the file is here. Then the data flows into this. In your computer, the buffer will be there. From the buffer, the media player will take the data and will play. So there in the buffer, there is high watermark and low watermark. That is, when it is high, that is, you have to stop. And then when it is low, you have to start. Or in between, to continue. All right? So these are safety ranges, safety measures for speeds, the difference in speeds. Like sometimes the transmission is slow, sometimes the media player is slow or whatever. To compensate for those things, this is there. When the media is created, it is the intention that media is to be delivered to the user at precisely the same speed as used for its creation. A song that lasted 4 minutes when sung for the recording would sound very peculiar if, when it is received by a user, it lasts 6 minutes. That means slow speed. Slow speed, you will get very funny sounds, not the normal voice. So it has to be played at the original speed. A relatively poor quality video can be delivered at a bit rate of 300 kbps, that is kilobits per second. But a reasonably good quality audio file only requires delivery at 128 kbps. The video needs more bandwidth. Even a poor quality one needs this much, but even a good quality audio, this is enough. Which means, in other words, video is heavier than audio. Data which is sent into the buffer should be sent at a higher rate to allow for unexpected delays. There can be unexpected delays. So because of that, more than the playing, the data should be sent at a higher rate. That is why you get the gray line in advance, so that there won't be any pauses. But if the gray line and the red line, the end of red line and the end of gray line coincide, like they are equal, then of course you have to stop. It will pause and wait until sufficient bits are collected in the buffer to continue or resume playing. It is essential to have a buffer size that is sufficiently large for it never to get filled. That is also important. The size should be large, otherwise if it gets filled, then also there is a problem. The rate of transmission to the buffer is limited by the bandwidth of the network connection. So if the bandwidth is high, the transmission that will give more data, the rate will be higher. Otherwise, the rate will be lower. For good quality movie presentation, the broadband requirement is about 2.5 Mbps, 2.5 megabits per second. That's for a good quality movie presentation. Because this will not be available for all users, it is often the practice that an individual video is made available at different levels of compression. So this 2.5 Mbps may not be available to everyone. So because of that only you find when you want to download something, you can select the resolution or the quality, high quality or low quality. High quality needs higher rate of transmission. Low quality, low rate is enough. So the user can select. So let's look at these terms again. On demand, when the bitstream content is transmitted at a time chosen by the user. On demand, the user decides to download. Real time is when the bitstream content is transmitted as it is produced. For example, in a Zoom meeting, like a transmission, live transmission, it goes to the other side at that time. Bit rate, the number of bits transmitted per second. And here is a task for you. Consider a bit streaming scenario for a video where the following values apply. The buffer size is 1 megabytes, right? Not megabytes, megabytes. The low watermark is set at 100 kilobytes. The high watermark is set at 900 kilobytes. The incoming data rate is 1 Mbps. Video display rate is 300 kbps. So all the data are given. Assume that the video is playing and that the buffer content has dropped to the low watermark. The media player sets the controls for data input to begin again. Calculate the amount of data that will be input to the buffer in 2 seconds and the amount of data that will be removed from the buffer in the same time period. So that's the question we have to do first. So if you take this diagram, also it's easy. So yeah, let's look whether I have taken the data correctly. The buffer size is 1 megabyte. So this is maybe 1 megabyte. Or what is this I have done? 8 maybe bits. I have told you before also that capital B is for byte and simple B is for bits. So it's converted to the size is 8 maybe bits because the speeds and all that are given in bits. The low watermark is set at 100. So from starting from here, going up, filling up, and this becomes 100 kilobytes. The high watermark is at 900. So it's going filling 300, 400, 500, 700, 800, 900. Then the balance 100 is there to fill up the whole thing altogether. So much, right? Then the incoming data rate is 1 Mbps, right? Video display rate is 300. So the outgoing is 300 kbps, slower than the incoming. So answer, when you answer, you have to say in 1 second, amount of data input is this one, no? 1 Mbp per second. Per second. Bits. Megabits. So then for 2 seconds, 2 megabytes, no? 2 megabits. So then what do you do? 2 into 10 to the power 6 because bits in bits form, the megabit first to kilobits is 10 to the power 3. And then again, when you take 10 to the power 6, it will get you into mega level. Mega level. Then what? To get it in bytes, take the same amount, divide by 8. Then it becomes bytes. And the other side, so this is the amount of bytes that will be sent in 1 second inside. Then going out, 1 second amount of data output 300 KB, kbps, kilobits. And to convert it into bytes, divide by 8. So 300 KB. Then for 2 seconds, our requirement is, the question says for 2 seconds. So 600, that is multiplied by 2, it will become 600 divided by 8. So difference is this 700, come in 1000, go out 300. So there's a difference of 7. And you continue the thing for 4, 6, and repeat the calculation for 4, 6, 8, 10, and 12 seconds. You must do like this again and again, so that we will become familiar with it. Then we come to IP addressing. That is used to define from where and to where data is being transmitted. So we are using IPv4 addressing at the moment, but no longer enough to cover all the devices expected to use the internet in future. Because it's based on 32 bits, that will be 2 to the power 32 different addresses, which is approximately 4 billion addresses. And you know, the world, half of the world population is using internet, it seems. That's found. They are found. So what's the world population? 8 billion. And half of it is 4. So we have already reached the maximum for these 32 bits is 4 billion approximately. So that we'll find that we are going to IPv6 addressing. Because of that, you need more bits. That has 128 bits. So first the net ID, then the host ID. So first of all, the IP address is, as I told you, it's an address from where to where. You're sending some data from where to where. So there is sender IP, receive IP. Like if you're sending a letter, sender's address, receiver's address. The postman will look at the envelope and then say, is the place to deliver it, and it delivers. Same way here. But when he delivers the letter, he won't look at the number first. Number 123, Call Road, Ratmalana. He looks at the last one first, the city, the Ratmalana. Then when you find Ratmalana, you go up to the other level and see which road. Then when you go to that road, you go to the upper level where there's a lane. In that lane only, that 123 or whatever, that house number will be there. Same way, this is first the net ID. Part of the IP address is, first part is the net ID, then the host ID. So the network, you are connected to a network, your ISP or whatever, you are connected to a network. So first that one, then the host ID is your own part, the user ID, user part of the IP address. Then IPv4 address is 32-bit long hierarchical address of a device on the internet. So each device connected to the internet must have an IP address, Internet Protocol address. Address structure for 3 classes of IPv4 addresses. So there are classes, they are classified. They are classified, and the classes are class A, B, and C. Class identifier here is 0. Number of bits for the net ID, the first part, 7. Number of bits for host ID, 24. So the total is 24 plus 731. And this is not a number to be taken, this is 1 bit. Class identifier 0 means 1 bit. So 32, 24 plus 7 plus 1, 32. Class B, the identifier is 10 and the number of bits for the net ID increases and the host ID decreases. So 16 plus 14 is 30. 30 plus 2 bits here, 32. And here, 8 plus 21 is 29, plus 3 here, 32. That is how the 32 bits are made up of. Before considering some of these, the representation used for an IP address needs to be introduced. During transmission, the technology is based on the 32-bit binary code for the address. Something like this. To make it simpler for users, we write the address using decimal numbers separated by dots. Each byte is written as the dinar equivalent of the binary number represented by the binary code. For example, the 32-bit code, this one, there are 4 bytes, 1, 2, 3, 4, is written in dotted decimal notation as 128 dot, dotted decimal notation. Remember, dots. Very important to remember this. If you are asked to write on the format of a IPv4 address. Later on, IPv6 address also you have to learn. So this is, what's the value of this byte? 1, 2, 4, 8, 16, 32, 64, 128. Remember our binary counting, 128 here. And this byte, 1, 2, 4, 8. 8 plus 4 is 12. Yes. And here, 0, 1, 1, 0 is 2. This is 30. 1, 2, 4, 8, 16. 16 plus 8, 24. 24 plus 4 is 28. Plus 2 is 30. Yes, that's right. So have a good look. This is the binary number for the particular IP address. And this is the dotted decimal notation for the same address. Now there is a thing called classless interdomain routing, CIDR. Add an 8-bit suffix. What is suffix? Suffix is at the end. Prefix is at the beginning. If you add something at the beginning, it's prefix. And at the end, suffix. So 8-bit suffix, there are 8 bits here to the address that specifies the number of bits for the net ID. So this will specify how many bits for the net ID. How much? 1, 2, 4, 8, 16. 16 plus 4 is 20. 20 plus 1 is 21. So there should be 1, 2, 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this, so out of this, say the stream, this part is taken as the net ID. How to identify the net ID? This will tell, okay, take my first 21 bits. That will show you the net ID. Then the balance automatically is a host. So 21 plus this should be 32. Dotted decimal notation, 195, 12.6, 14. That is, if you to convert this, you will get, this is first byte is 195, the other one 12, 6, 14, the final one. And this slash and 21 is this decimal, slash 21, the value of this suffix. A CIDR IPv4 address. Another task, create an example of the binary code for a class C address expressed in CIDR format. Give the corresponding dotted decimal representation. So I think you should be able to do that now. If you can't do it, to find it you can't, then you have to go back to you watch this video again, read the tutorial which is available, then attempt again, then you will be able to do it. So now we are talking about new thing, subnetting. The network addresses and all that, subnetting. Here is the internet, connecting LANs using the original classful IPv4 scheme. Original IPv4 scheme. It's a medium-sized organization. This is the head office. There are 2, 4, 6 LANs, 1, 2, 3, 4, 5, 6, and each one has a gateway. Without the gateway, you can't connect directly to this. So 150 employees are there, 6 individual department LANs, plus one head office LAN. This is head office LAN, plus 6 individual department LANs. What do? You take all those, the gateways, these gateways, there are 6, 7 gateways. Yeah. You take all those gateways and put one router. These are connected. Connecting LANs using subnetting. So if you know the subnet ID and all that, then you can use this method. And finally, network address translation. There has to be a translation for this kind of thing. There's an internal router and the others are connected to this, and there should be a NAT box, network address translation. Then only it can be identified properly. An intranet connected to the internet using a NAT box. So then it becomes an extranet, because intranet is usually not connected to the internet. So when an intranet is connected to the internet, it becomes an extranet. It's called an extranet. This is an internal router. This is an internal router. Intranet is a secure. Internet is secure as not connected to the internet. So intranet, the definition is a network, local area network, using internet technology. That is, you can have web pages, and have email, chatting, all the facilities available on the internet using the same technology you can have in the local area network, but not connected to the internet. Therefore, it is surely safe from the outside dangers. But organizations want extranets. Are they? Then NAT is needed. Extranet is when it is connected to the internet. So for that, the network the address translator is needed. Network address translator is needed, NAT. The NAT box has one IP address. This has only one IP. You need not have many IPs for individual, which is visible over the internet. So this address only is visible to the internet. There are other local IPs there, we'll learn it. Internally, the IP addresses used as a sending address or as a receiving address. Internally, the IP addresses have to be chosen from one of the 3 ranges of IP addresses shown in table 2.03. So internally, you can have same addresses which another network will use, but not this. This has to be unique, the IP address of this, but internally, they are given chance to reuse according to this. Now, you may be already aware or familiar with this 192.168. That kind of thing. The upper bound is from here 0 to 255, this one 0 to 255, where you can't have more than 255 in a byte. These two also available, 10, 0, 0, 0, 0, 2, 10, 255, 255, 255, and 172 range. These are not visible. Now, if you have this as your address, it's not visible to the outside world. Outside world, only the NAT address, the NAT IP will be visible. So that is not for these individual ones, remember, for organizations. Now, there are 2 kinds of IP addresses, static and dynamic IP addresses. ISP has an allocated number of connections. Let's say ISP has 1,000 connections, but there are more customers. Physically, they can give only 1,000, but there are more customers than 1,000. How do you manage? The one who uses this particular IP address the moment to log off from the internet, it can be reused to or used by another user. But ISP can give connections to more customers as all do not use internet at the same time. ISP can give same IP address to another user once the first user disconnects. So if you connect again, you will not get the earlier address. That is why it's dynamic. It's changing. Half an hour ago, you used one IP. Now, 1 hour later or half an hour later, you want to use again, login. It's a different IP. So customer ISP can give same IP address to another user once the first user disconnects. Customer doesn't get same IP address always. You can't have one IP address. That's why it's called dynamic IP address. But what about static address? Customer has to pay more to get a static IP address. But you and I don't need a static address. Then who needs? Who has to pay more? If you have a website on your own, it's hosted on your computer, then you have to have a static IP address because IP address is the translation of your URL. So users can't be changing the URL time to time. It has to be static. Same URL. But you have to pay more for that. Then IPv6 addressing, we talked about the number of users and why IPv4 is not enough. Now IPv6 uses 128 bits. That gives you 2 to the power 128 different addresses. Huge amount. What is the format? Colon, hexadecimal notation. Earlier, dotted decimal notation. Yeah, colon, hexadecimal notation. Remember the words. So colon is the separator here. Is a separator. And the hexadecimal, the values given. So your full address here is this 68E6, all hexadecimal digits, and then separated by colon. How many? 1, 2, 3, 4, 5, 6, 7, 8. So each number here is 4 nibbles. What is a nibble? Half a byte. So each hexadecimal digit, as you know, needs half a byte. 4 bits. Each hexadecimal digit, you need 4 bits, that is half a byte, or the other term is nibble. So altogether, how many? 128 bits. Here, how many? 4, 8, and that will be 16 bits here. So 16 into 8. Right? Each number has 16 bits into 8. That is 128. Which will give you this amount of addresses, 2 to the power 128. What is this? Has been replaced by the 000, two numbers with zeros is 3 colons, 1, 2, 3. Replaced by 2 colons. So we have this in between. This is not written. In place of that, we have put 2 colons. And this is leading zeros omitted. So you can have this 23. Without 0023, you can have just 23. And this is an IPv4 address used in IPv6. So here in front, if you have 2 colons and this one, that's a IPv4 address. Same format you can have. Some examples of IPv6 addresses. Domain names. Finally, we come to domain names. Currently, every email address and every web page has an IP address allocated. Since we cannot remember and type IP addresses in that format, DNS, which was introduced in 1983. DNS is domain name server or service. The naming system is hierarchical. There are more than 250 top-level domains which are either generic, example, com, edu, gone, or represent countries, example, UK, NL, .lk, like that. So domain name service again, a hierarchical distributed database installed on domain name servers. They are all around, all over the world, everywhere they have volunteers have set up these servers. Otherwise, it will take a long time to get to your destination URL. This is responsible for mapping a domain name to an IP address. Without getting the correct IP address, you can't reach the host through the net ID and then the host ID. Also known as domain name system. So this is also called domain name system. That marks the end of chapter 2. Hope you will watch this and improve your knowledge.